Next, we'll take a look at existence proofs. First one is a constructive proof, and this involves simply finding the element in the domain that exists. If you can find the element, then this is a fantastic way to prove the existence of an element in the domain set. However, many times you cannot find that existence of an element, so you end up with a non-constructive proof as your only option. So that tends to be, if you can't find the element that exists, you can try the non-constructive proof. And what you're trying to show there is that there exists an x in your function p of x. One common way to do this is with a proof by contradiction, showing that the negation of there exists quantification implies a contradiction. So for our first example, for our existence proof, we'll take a look at this one. Prove that there is a positive integer that equals the sum of the positive integers not exceeding it. So we'll choose a constructive, and what we're trying to show is that there exists an x such that x is equal to the sum of all the x's before it, x1, x2, up through xn, where xn is less than or equal to x. So that's the setup of the problem. And now all we're trying to do is come up with a constructive example to show that there exists some x that this is true for. Not that this is true for all x, simply that this is true for an x. And all we have to do is find one. So here we can say, okay, let the number be 1. So we'll have 1 is equal to 0 plus 1. 1 is indeed equal to 1. Therefore, this is true. Fantastic. First one done.